Welcome to the fourth session of our lecture series. So, unfortunately, I'm unable to do the lesson as a live class because I have a conference to participate on this Sunday. So I decided to do a recording and complete this session. For both modules, I will give you the content as a recording. So please refer the recording, take time, ask the PowerPoint presentation from your coordinator, refer it, and if you have any issues, if you have any clarification, please take all these things to the next live class. So this is a very urgent and very ad hoc meeting, so conference actually. So I had to confirm my participation yesterday, and today is Saturday. So quickly I have to schedule everything for the conference. So I extremely apologize for my inconvenience. So that is why I decided to do this as a recording. So in this lesson, basically I discuss about network devices. So if you remember, in our previous session also, I took a small part regarding network devices and I discuss things there. So here what I'm going to do is, I'm going to deeply discuss about these network devices. Because in this computer network and internet, the basic thing you can see, you can understand is those devices. Whenever you see a computer, whenever you see a router or something like that, you try to understand it as a network. So here also we are doing the same thing. We are discussing about networking devices. It is the building block of modern networks. Let's discuss what we are going to check in our lesson. So this is the agenda for the today's lesson. So at the very beginning, I will discuss the foundation. So under foundation, I will discuss the basic devices and the OSI model. When it comes to network, internet, we can't ignore this OSI model. So I will be discussing that part with you. And then we have something called the control center, where we control our overall network. So under that, I mainly focus about switches and routers. The third lesson that we are going to cover is LAN, local area network. This is where we basically start industrial networks. So when we have a requirement, we start from a LAN, local area network. So that is why I wanted to specialize this thing here. So under third session, we will be discussing about LAN and something beyond that. And the fourth part is specialized and security devices. When it comes to network, we expose ourselves to the world. So when we expose ourselves, our details, our information, data, we have to concern how we secure those things, how we protect those data. So under that, we have few things to concern. So we will be discussing about firewalls, load balancers, and more. And finally, I want to take all these things together and give you that overall idea. So these are the things I'm going to discuss in today's session. So the learning objectives, we have basically three learning objectives. Identify key networking devices, that is the main purpose of doing this lesson. And then we focus about explain core functions. We try to understand the primary role of each device in network communication, and then I will be describe the device interactions. So those are the things I'm going to focus and I'm going to target in this lesson. So let's start with a network. So here I'm going to discuss what is a network. A network fundamentally consists of two or more interconnected computers. As you all know, network is interconnected devices. So if you want to share something, if you want to communicate with someone, so you use devices to develop a small network. So with that, you gradually develop this kind of platform. So when we discuss about this network, we have few things to concern and we have few terms to concern. For an example, data, packets, frames. So I would like to explain what is data information broken down into packets from efficient travel across networks. So when it comes to data, you may hear this thing. We have two things called data and information. So data is raw fact. We can't take any decisions, we can't proceed with data. But when it comes to information, we can make decisions based on that. Those are not raw data. After doing some processing to data, we can take information. So here we mainly focus about data in networks because we break down data into small pieces and then we send here and there using this concept packets. So packet is like a small container. We put some amount of data to that packet and we send those packets through the network. So those are like small bags. We put some amount of data and we send those data as a packet. And then we have something called frames. These are the packets with additional formatting and control information for transmission. So to control the way these things are going, the control how these things are receiving and sending, we have something called frames. So these are very frequently used terms in a network. So you can understand this thing with our lesson. So, and when it comes to network types, we already discussed this thing with our previous lesson. We have five types of network. We have the personal area network, then we have LAN, then we have MAN. So like that, we have few types of networks. So in this lesson, I mainly focus LAN and WAN. LAN is where we start developing these commercial networks, and WAN is the largest and the biggest network. So these are the two types. So y'all can consider these two and y'all can understand what is these two with more in this lesson. So here you have a small illustration, a small diagram to understand about network. So here we have a computer and then we have another computer here. You can see we have a Wi-Fi, server, printer. So we have few devices. All these are interconnected from these dotted lines, dashed line. You can understand it. So this is about network and all. So when it comes to network, these are the main things we usually focus. අපි networks ගැන කතා කරනකොට network එකක් කියලා කියන්නේ එකට connect වෙච්ච devices කීපයක්. එහෙම connect කරන්න ප්‍රධානම හේතුව තමයි data share කරගන්න එක. එහෙම නැත්නම් information share කරගන්න එක. අපිට මොනවා හරි ෂෙයා කරගන්න, කමියුනිකේට් කරගන්න ඕන හින්දා තමයි අපි නෙට්වර්ක් එකක් ඩිවලොප් කරන්නේ. දැන් මේ නෙට්වර්ක් ගැන කතා කරනකොට අපි නිතරම පාවිච්චි කරන terms තුනක් තියෙනවා. data, packets and frames. data කියලා කියන්නේ අපි මේ medium එක through යවන දේ. data තමයි එහාට මෙහාට යන්නේ. දැන් අපි කාට හරි call එකක් ගන්නකොට මගේ කටින් පිට වෙන්නේ data. ඒ වගේම wire එක දිගේ යන්නේ data. receiver ට ඇහෙන්නේ data. ඒව තමයි අපි data කියලා හඳුන්වන්නේ. packets කියන්නේ මේ data අර cable එක through wire එක through යන විදිය. දැන් මේ data packets විදිහට තමයි යන්නේ. දැන් packet එකක් කිව්වහම ඕගොල්ලන්ට අර ශැෂි packet එකක් වගේනේ ඔලුවට එන්නේ. ඔව්. ඒ විදිහට තමයි මෙතනත් data යන්නේ. අර cable එක ඇතුලේ පොඩි පොඩි segments වලට පොඩි පොඩි packets වලට තමයි data share කරන්නේ. And then we have another thing called frames. It is like the boundary. So we always have to consider these boundaries when we work with a network. And this is where we're going to discuss about OSI and TCP model, TCP/IP model. So first, I would like to pay your attention to OSI 7-layer model. So this is very popular in networking, in all network courses, in all network programs, in all network lessons, we have this 7-layer because this is the theory behind a network. So when it comes to a network, we have to practically implement that. Step by step, we have to practically implement that. So these are the layers we usually go through and we will follow when we develop this OSI 7-layer model. So I would like to start with the last model, last layer. It is number 7, the top layer in this framework. It is the application. So application is where we can see devices. So network user interfaces are there. For all these things, we use application. So this is the end result. So we do so many things, we develop the network, we do wiring, we do cabling. Finally, we receive this internet through a cable to a device. So those layer we consider as the application. Basically, user will engage with this application layer. දැන් අපි network එකක් ගත්තාම මේ network එක අපිට පුළුවන් layers කීපයකට බෙදන්න. ඇත්තටම මේක අපි develop කරා නම් මේ layers කීපයට තමයි අපි network එක develop කරන්නේ. අපිට බැලූ බැල්මට මෙතන layers කීපයක් තියෙනවා කියලා පේන්නේ නැහැ. හැබැයි network ගැන දන්න කෙනෙක් මේක ඇත්තටම හරියට implement කරා නම් මේකේ layers 7ක් තියෙනවා. දැන් ඔය layers 7න් උඩම top එකේම තියෙන layer එක තමයි application layer එක. application layer එක කියලා කියන්නේ අපිට පේන layer එක. එහෙම නැත්නම් අපි පාවිච්චි කරන layer එක තමයි application layer කියලා කියන්නේ. මේ layer එකේ devices තියෙනවා. මේ හැමදේම තියෙන්නේ application layer එකේ. ඊට පස්සේ තියෙනවා presentation layer කියලා එකක්. presentation layer එකේදී වෙන්නේ data ඔයාගේ device එකට present කරන එක. So this is where we send data to your device. And then we have something called session. So session always consider the connection management. So it check the connection, it check whether you have logged into a particular network, the pathway, everything checked by this session part. And then we have transport. So transport layer always concerned about the transportation. From this point to this point, we transport data. And then we have network. So network is we have to logically address. We have to find the IP address of a certain computer and then we can develop a connection with that. So this is where we do all these things. We call this as network. And then the second layer is data link. So where we find the addresses of other devices. And the bottom layer is physical. So in this physical layer, we mainly consider about something called bit transmission. So bits are the values or the data behind this mechanism. So we use something called bit transmission in the physical layer. And then we have TCP and IP four-layer model. So this is something different than the previous one. Green color one is, we called it as OSI 7-layer model. And this is the orange color one is another model that also popular. It is TCP and IP 4-layer model. So in this layer also we have basically 4 layers: application, transport, internet, network, interface. So here we have a network interface where we consider Ethernet, Wi-Fi, router, those kind of things. And then we have something called transport where we send data from one place to another place. Then internet where we do the connection with IP, ICMP. And then we have HTTP, FTP, SMTP. So you may know this thing. Whenever we access to a website, we see HTTP, HTTPS before the URL, before the website. So we called it as application layer. So application layer is the topmost layer where we discuss, where we communicate with internet and all. So now we are going to jump into the main part, because in our lesson, I want to mainly focus the devices that we are going to focus. So under devices, I would like to first discuss about cables and connectors. Because in order to develop the network, the first and foremost thing is cable and connectors. So without cables, we can't do the network. කේබල් කියලා කියන්නේ අපේ network එකේ තියෙන importantම දේ. cables නැතුව අපිට network එකක් develop කරන්න බෑ. When it comes to cable, students, we have basically 2 types of cable. So last week also I discussed this thing. The 2 types of cables are copper cable and fiber optic cable. So, what do you mean by copper cable? Uh, so we can see a copper layer, copper cover inside the cable. So here we have basically two types of copper cable: unshielded twisted pair, shielded twisted pair. So when it comes to unshielded twisted pair, we called it as UTP. And when it comes to shielded twisted pair, we called it as STP. So these are the two types of cables that we all can see. And I have give you a few examples to understand more about copper cables. So if you don't know anything about copper cables, please do a small research. Use ChatGPT or whatever the tool, and then do a small research on this thing. Right. So it is copper cable. And then we have something called fiber optic cable. So this also very popular, and we can see glass or plastic stands in this type of cable. So we have this ability to transmit data using lights. So the main advantage in this fiber optic cable is it is high bandwidth, long distance. High bandwidth in the sense at a given time we can send high amount of data. ඒ කියන්නේ එක වෙලාවකදී data ගොඩක් අපිට send කරන්න පුළුවන්. ඒකට තමයි high bandwidth කියලා කියන්නේ. Then long distance. ඒ වගේම ගොඩක් දුරට අපිට මේක send කරන්න පුළුවන්. ඒක efficient. දැන් ගොඩක් වෙලාවට දැනට තියෙන cables වල එහෙම නැත්නම් දැනට තියෙන implementation වල ගොඩක් වෙලාවට මේ fiber optics ඒ කියන්නේ fiber cables තමයි use කරන්නේ. ඒක හොඳ example එකක්. දැන් ගොඩක් වෙලාවට ඔයගොල්ලෝ ටෙලිකොම් මොකක් හරි ඉන්ටර්නෙට් කනෙක්ෂන් එකක් ගන්න බලාගෙන ඉන්නවා නම් හරි ඔයගොල්ලන්ට එක්ස්පීරියන්ස් තියෙනවා නම් ඒව අරගෙන එතනදී ගොඩක් වෙලාවට fiber optic cables තමයි දැනට use කරන්නේ. ඉස්සර නම් copper cables පාවිච්චි කරා. හැබැයි ඒකේ ස්පීඩ් එක මදි. ඒ වගේම එකපාර send කරන්න පුළුවන් data ප්‍රමාණය අඩුයි. ඒ නිසා ඒක ගොඩක් වෙලාවට shift වෙනවා fiber optics cables වලට. So then we are going to discuss about the first device. It is the network interface card. So if you have any experience using a data cable to access internet, you know what is this port. So in this picture, you can see this port. This is where we connect that cable to the computer. දැන් ඔගොල්ලෝ කවුරු හරි network cable එකකින් internet access කරලා තියෙනවා නම් ඔයගලන්ට ඒක මතක ඇති දන්නවා ඇති අපි cable එක අරගෙන නිල් පාට cable එකක් බොහෝ දුරට එන්නේ ඒ cable එක මෙන්න මේ port එකට connect කරන්න ඕනේ මේක තියෙන්නේ ඔයාගේ lap එකේ ඒක ඇතුලේ තියෙන්නේ මෙන්න මේ වගේ කෑල්ලක් ඔයාට පේන්නේ එළියට මේක විතරයි මේ කෑල්ලට තමයි අපි කියන්නේ the network interface card කියලා. A network interface is a hardware component that allows a computer to connect to a network, serving as the physical interface between the device and the network. So your device is the computer or internet or whatever the thing. So you can get the internet connection through this cable. So this will automatically connect to this NIC. So then the circuit will work. Through that you can get the internet connection. So I have listed some key features of this NIC. Basically, it is a circuit. So when you see this picture, you can see it is a full of circuit. We want to operate the network, we want to operate the internet. So we use this thing. So inside our computer, we have this NIC. So it has a unique MAC address. Whenever you connect a computer device or whatever the thing to this connector, it will work, which means it has a unique address. And then layer 2 operation, we put this under data link layer because we link the data, through that we access thing. And then network connectivity. So we connect the network. So these are the things we consider as the key features. I'm not going to explain everything because these are not much mandatory for your level. Whatever the whatever the device, you can understand it. If you can recognize it when you see the picture, that's totally enough. So if I tell you how this NIC actually works, the NIC establishes a physical connection to the network through ports like RJ445, and it converts digital data to signals transmission. So that is what we basically do in this NIC. So without this NIC, you can't get that Ethernet connection. Ethernet connection in the sense we connect a cable. Through that cable, we do the work. And then we have another device called repeater. So I would like to explain what is repeater exactly. So uh, it is a simple device that regenerates and amplifies network signal. So you can regenerate the signal. So you know when we do a communication for long distance, then when your voice goes to there, some distractions can be happen. So what we do is time to time we regenerate the original voice or the signal and we amplified it. So then what we try here, we try without reducing the quality, we try to send those information, those things to the receiver. So that is what the repeater and amplifier does. it like uh, strengthen the signal. So without breaking the signal, you can easily and you can quickly, with the quality you can send with the repeater. And it extends transmission range when signals degrade over long distance. So we have something called uh, signal degrade in the sense it will low down the quality of the signal. දැන් ගොඩක් වෙලාවට අපි කිට්ටුව තැනකට data share කරනවා නම් එහෙම නැත්නම් signal එකක් දෙනවා නම් ඒක ඉක්මනට quality විදියට ගන්න පුළුවන් මොකද distance එක අඩු හින්දා. හැබැයි distance එක ගොඩක් වැඩි වෙනකොට මේකට එන distractions වැඩි. ඒ නිසා සිග්නල් එකේ quality එක ගොඩක් වෙලාවට අඩු වෙනවා. ඕක නැති කරන්නම බෑ. අඩු කරන්න තමයි මේ repeater එක එහෙම නැත්නම් amplifier එක use කරන්නේ. එයා නිකන් ආයෙ generate කරනවා මේ original signal එක generate කරලා ඒක amplify කරනවා. ඒ කියන්නේ ඒක strength කරනවා receiver ට යනකම්ම. So we put this under layer 1, under physical layer in the OSI model. So some limitations are there in these repeaters. No intelligence, routine or filtering, increased network congestion and collision, not suitable for modern networks. So most of the time nowadays we are not using this thing because this is not a modern gadget. So and it doesn't has a intelligent. So what it does, it repeat the same thing again and again. So we called it as repeaters most of the time. When we do very distance communication, those days we use these repeaters. And the next thing is hub. So I would like to discuss about the hub. So what is hub? A hub is a multi-port repeater that connects multiple network devices. So we called it as the hub, which means you can connect multiple devices to this hub. We called it as hub. A hub is a multi-port repeater that connects multiple network devices. It operates at one physical layer. So this is the hub. So it has a one cable, but we can connect multiple devices to this hub. දැන් මේ hub එකට තියෙන එක cable එකයි. හැබැයි hub එකට අපිට තව cables ගොඩක් connect කරන්න පුළුවන්. So this is a picture of a hub. And here this is how it works. So it broadcasts all incoming data to every connected port, and it does not process or filter data packets. Functions as a dumb device in the network. So this is where we connect all these things together. So we called it as the hub. ගොඩක් වෙලාවට මේ hub කියන එක අපි use කරනවා. ඒ use කරන්නේ අපි මේ වගේ connect කරන්න devices ගොඩක් තියෙනකොට ඒකට අපිට මේක use කරන්න පුළුවන්. example එකක් විදිහට දැන් හිතන්න ඔයා මේ lap එකෙන් මොකක් හරි වීඩියෝ එකක් කරනවා. ලැප් එකේ කැම් එක නෙමෙයි යූස් කරන්නේ වෙන කැම් එකක්. ඔයාගේ ඉස්සරහා වෙන කැම් එකක් තියෙනවා. ඒකත් ලැප් එකට කනෙක්ට් කරන්න ඕනේ. ඊට පස්සේ තව ඔයා හිතන්න දැන් නිවුස් කියනකොට ඒ නිවුස් කියන කෙනාට අර නිවුස් එක කැමරාවේ ස්ක්‍රීන් එකකින් පෙන්නනවා. අපිට පේන්නේ යා කටපාඩමින් කියනවා වගේ. හැබැයි යාට ඉස්සරහා ඒ ටික ඩිස්ප්ලේ වෙනවා. අපි ඒකට ටෙලිප්‍රොම්ප්ටර් කියලා කියනවා. එතකොට ටෙලිප්‍රොම්ප්ටර් එකක් තියෙනවා. මේ දෙකම ඔයා කනෙක්ට් කරන්න ඕන ඔයාගේ කම්පියුටර් එකට. වීඩියෝ එක ගන්න. දැන් එතනදී ඔයාට මේ හබ් එකක් නැත්තම් ඒ දේ කරන්න බෑ. මොකද කේබල්ස් දෙකක් තියෙනවා ඔයාගේ කම්පියුටර් එකට කනෙක්ට් කරන්න. සමහර වෙලාවට සවුන්ඩ්ස් තව වෙන මොනවා හරි කනෙක්ට් කරන්න වුණොත් තව කේබල්ස් එකතු වෙනවා. ඒ ඔක්කොම ඔයාගේ කම්පියුටර් එකට කනෙක්ට් කරන්න පුළුවන් හබ් එකක් through. දැන් මෙන්න මේ මෙතන තියෙන කේබල් එකෙන් ඔයාගේ කම්පියුටර් එකට මේක කනෙක්ට් කරනවා. මේ තියෙන්නේ ඔක්කොම ඩිවයිසස් ටික කනෙක්ට් කරලා තියෙන එක. ඒ කියන්නේ ඩිවයිසස් කීපයක් ඔයාගේ කම්පියුටර් එකට කනෙක්ට් කරන්න තියෙන එක විදියක් තමයි හබ් එක කියලා කියන්නේ. So we have some inefficient factors and security risk in this hub. The inefficient factor is it creates collision and waste bandwidth. Yeah, that can be happen because we double the bandwidth because of that issue. It can be inefficient. So this is how it works. Right. The next thing, the switch, we called it as intelligent hub. So, what you mean by the intelligent hub? It operates at layer 2. So, data link layer of the OSI model. And we basically consider the MAC addresses, unicast communication. We can improve the performance with this intelligent hub. So this is very advanced hub than a usual one. Most of the time we see this kind of hub in networks. And then you should understand what is this MAC address table. So when it comes to a MAC address table, it is something like this. So you can see. So in this MAC address table, students, we have this kind of unique addresses. හරියට නිකම් මේක අපේ city එකේ තියෙන ගෙවල් list එකේ addresses වගේ. දැන් ඔයාගේ device එක තව devices කීපයකට connect කරනවා නම් මේ MAC address එක through තමයි connect කරන්නේ. තව device එකක් ඔයාට හොයාගන්න තියෙන address එක. ඒ ටික list down කරලා තියෙන table එකට තමයි we called as MAC address table. And this is the step-by-step process of doing this thing. Step 1 is learning. So switch examine incoming frames and learns the sources of MAC address. So if it is a network, first it will analyze what are the connected devices or what are the devices we supposed to connect. And then it will search the addresses of those devices. So that is we call as learning. And then step 2, table building. It creates entry mapping MAC address to incoming port. So it is like we create a table. So when we create a table, we know what are the addresses and what are the places that we are going to incorporate. And then step 3 is forwarding. It checks destination MAC and forwards to specific port. So if you want to send something to a computer, then you have to find the MAC address of A from this table and you can send data. And the step 4 is flooding. If MAC unknown, floods to all ports like hub. So this is what we call as the MAC address table. For the efficient and effective network, for efficient and effective communication, we use this MAC address table. And then I'm going to discuss about the two types of switches, unmanaged and managed. This is very popular and we can see very practical example to these two types. Before I explain it to you, I would like to give you 2 to 3 minutes to quickly go through these two types and understand it by yourself. Then I will explain it to you. So what is this unmanaged and managed switches? So when it comes to unmanaged switches, we do plug and play. We don't have proper management there. So no need to do a configuration, no need to go for advanced settings. We can just plug and play. So this is very ideal for home networks and small offices. And this is very cost effective because whenever we need, we can remove this thing. Whenever we want, we can plug this thing. And when it comes to the opposite side, the manage switches, basically we have a few advanced configurations. For an example, VLAN, QoS, SNMP, those are the configurations we have to concern when it comes to manage switches. And this is ideal for business and enterprise environment. Someone who can afford this thing, someone who can pay for this thing. This is the suitable thing for businesses and enterprise environment. Because when it comes to business and enterprise, we have huge devices, huge number of devices to connect. So whenever you go that kind of environment, it's the best option. And not only that, this will improve the security because this has features, manage features to do this security and all. It has some access control, it has some security policies. So all these are very suitable for businesses and enterprise environment. And the cost also expensive than the unmanaged switches. So these are the basic two types and you can understand the difference with this. And the fourth device we are going to discuss today is the router. So we consider this as the gateway of the network. It is the gate. It is where we open the doors to access the network. We called it as the gateway or the router. So I have included a small picture to understand the router and how it works. So here we have a router. And then we have two networks, LAN and WAN. So router is the gate to give you the access to both LAN and WAN. It is like a door. These are the key features of the router. We have layer 3 operation, routing decisions, routing table, and routing protocols. So when it comes to layer 3 operation, it operates at the network layer of OSI model. So we always take this OSI model because in there we can easily understand the place of each these device, where we place this thing, where we put this thing. So that is we call as the router. And it will take some decisions we called as routing decisions. It determines the optimal path for data packets to travel between different networks. And here also we have something called routing table where we record all details about the routing. And then we have something called routing protocols. So this is how we develop the routing table. This is same as the MAC address table. So the routing table is something like this. We record the address, the data details, packet details in one place. We called it as routing table. And I have listed some key components: destination network, next hop, interface. So this is how it works actually. We have the router here, and then we have the routing table where we record all these details. And then we have network B, we have network A. So this is how this thing works. So router receives a packet with a destination IP address. Router examines the destination IP and consult its routing table. So here a small summary to understand the difference between switch and a router. So we have few features here: the layer, addressing, domain, primary function. So I would like to take these two and discuss the features. When it comes to layer, switch belongs to layer 2. You can quickly go back to the OSI model and you can check what is layer 2. I'm not going to re-explain that thing here. And we put router to layer 3. It's belong to network. And when we do switching, we mainly focus the MAC address of the device. And when we do routing, we mainly focus the IP address. And in switch, we have single broadcast domains, we have multiple domains. But when it comes to router, it's multiple broadcast and multiple collision domains. And the primary function of switch is connect devices with a single network, and router connect different networks. So that is the main difference between a switch and a router. Right. So we are going to jump into the next thing. Here we are going to discuss about another important device. We called it as the modem. So let's see what is modem, what we are going to do that, and few examples for that. So the uh, meaning behind this modem is it is modulator, demodulator, a device that. So I always take this example to explain this device. So let's say here I'm going to take a call to someone. So here I use my land phone. My friend also using the same thing. So when I talk to my friend can hear my voice. But that voice will go through a medium. If it is wired, it will go through a wire or a cable, and then what we do here is we take the voice. So I'm the one who is speaking. So then it will take my voice and then it will convert it to a digital signal because my voice can't travel through that cable. දැන් මම මේ කතා කරන විදියටම ඒ සද්දෙට වොයිස් එක තව කෙනෙක්ට ෂෙයා වෙන්නේ නැහැ. එතනදී හැමතිස්සෙම අපේ සිග්නල් එක ඩිජිටල් සිග්නල් එකකට කන්වර්ට් වෙලා තමයි අනිත් පාර්ශවයට මේක ෂෙයා වෙන්නේ. එක්සාම්පල් එකක් විදිහට මම කතා කරන සිග්නල් එකට අපි කියන්නේ ඒ වචනවලට කියන්නේ අපි ඇනලොග් සිග්නල්ස් කියලා. මේ ඇනලොග් සිග්නල් එක අපි ඩිජිටල් සිග්නල් එකකට කන්වර්ට් කරාට පස්සේ ඒක අර කේබල් එක through එහෙම නැත්නම් එයා එක through අපිට ෂෙයා කරන්න පුළුවන්. right? දැන් ඒක තමයි ඔය මොඩම් එකකින් කරන ප්‍රධානම දේ. දැන් මම කතා කරන තැනත් මොඩම් එකක් තියෙනවා. ඒ වගේම මම කතා කරන එක ඇහෙන කෙනා ගාවත් මොඩම් එකක් තියෙනවා. So I will take a small drawing to explain this thing. So let me draw and explain how this thing working. So let's assume here this is my phone and this is you, this is your phone, and let's assume we are connecting with a wire. So now I'm speaking. So when I'm speaking, it has to travel that thing through this medium. But it can't travel as the way I speak. So I have to convert this into a digital signal which we can share through this medium. So here we have a small device called modem. It converts my voice to a digital signal and then it will share through the medium. And now I can't understand those digital signals. I want to convert that digital signal again to my voice or analog signal. So here we have another device called demodulator. It converts this digital signal into a voice or analog signal. So this is where we use modulator and demodulator. දැන් ගොඩක් වෙලාවට එක පැත්තක මොඩියුලේට් එකක් යූස් කරනවා නම් අනිත් පැත්තේ තියෙන්නේ ඩීමොඩියුලේට් එක. So that is the basic thing behind modem. We call that as a modem. So modem translate digital signals from your LAN into analog signal. And it converts analog signal back into digital data. ඔය analog signals කියන්නේ ඔයා කතා කරන ඔයාගේ voice එක. ඒක digital signal එකකට convert කළා තමයි අර medium එක through share කරන්නේ. ඒ වගේ මේක receiver ගාවට ගියාම එයාට මේක ඇහෙන්නේ නැහැ. මොකද ඒක digital. ඒක convert කරන්න ඕනේ ආපහු analog signal එකකට. So that is what we call as analog signals and digital signals. So then we have a wireless router. So this is very frequent, and you all know what is this thing. We called this as a wireless router. So we called it as Wi-Fi router in home, small office. We can see these routers. Whenever see router, we know we can access the internet. We can get the internet connection. Uh, so these are actually integrated components. So router manage traffic between your local network and the internet using IP address. But when it comes to switch, the device we discussed earlier, it provides wired Ethernet port for connecting devices like desktop computers and printers. So this is where we're going to discuss about wireless access point. So I would like to give you 2 to 3 minutes to quickly go through this and understand this by yourself first, because this is a kind of complex thing. Please go through this slide and try to understand, then I can explain it to you. Right. So what you can understand from the slide. So this is where we access the internet, and especially it is wireless, no wires. We called as wireless access point. It is a device that extend a wired network's reach by allowing wireless capable devices to connect to it. So it acts as a bridge between wired and wireless networks, and it converting wireless signals from devices into wired Ethernet signals and other components. So this is where we access the internet. We called as wireless. So now we are going to discuss about the security things and all. So when it comes to internet, students, we know we are exposing to the world. We are exposing outside. We are exposing to the outside world with the internet. So when you use Facebook, you expose yourself to the outside. Others can see your profile, others can check your status. So those are like the exposure we get with the internet. So in this exposure, we have both advantages and disadvantages. So the main disadvantage is security, because others can take your data, others can hack your profile. So those security related things can be happen. So now from this point onwards, I'm going to discuss what are the things, what are the components we can use to protect ourselves from all these things. The very first thing is the firewall. So the primary security gatekeeper for a network. So now you know in our houses we have a wall. Why we have a wall and a gate? Because we want to protect our premises. So we know who is accessing. If someone wants to access, they have to take the permission. So like that, you have to control outsiders. Same way, when we develop a computer, when we develop a computer network, we follow the same thing. To protect our network, we use something called firewall. This is not our usual wall. This is firewall. So it protect our data and our computer network from outsiders. So this is like a security antivirus related things. To protect your computer, you can establish a firewall. So its fundamental role is to filter incoming and outgoing network traffic based on a predefined set of security rules. And now we are going to discuss few specialized devices. As network grow in complexity and face increasing security challenges, specialized devices provide enhanced performance, security, and traffic management. So when we especially concern the security and all, we can't ignore these things. First one, layer 3 switch. A hybrid device combining switching and routing capabilities. So it performs routing at wire speed for high speed inter-VLAN routing. And then we have something called intrusion detection system, or in a practical environment, we called it as IDS. So it is a monitoring system that passively observes network traffic for suspicious patterns or known attack signatures. It always detect those things. It always filter out these things. We called it as intrusion detection system. And then we have another thing called intrusion prevention system, IPS, an active security system that detects and prevents malicious activities in real time, blocking or dropping malicious packets. So malicious in the sense unwanted things. If some unwanted thing is happening or it is detected, it will work with intrusion prevention system. And then we have something called load balancer. It is like balance the outside and inside related things. So it distributes incoming network traffic across multiple servers to ensure no single server becomes overwhelmed. It enhancing availability and performances. Right. So here we are discussing about the hybrid option. When we always discuss about the hybrid, it takes features from different platforms and try to get the optimized output. So we put this under layer 3 switch, and we combine features of the switches, and we develop the hybrid for the maximum output. And I have included some key features, and you can take some use cases, you can search, and you can understand how this the router switch work as a hybrid environment. And I would like to discuss more about intrusion detection and prevention system. So intrusion detection system is it detects if something happened, if someone tries to do something for the network, or if someone try to illegally take data from your computer, or illegally uh, what we call this as breach data. So this will detect those things. Detection is once something happen, it will try to stop that. We called it as intrusion detection system, a monitoring system that passively observes network traffic for suspicious patterns or known attack signatures. So it generates alerts for network administrators. It does not actively block traffic. It revives traffic for known attack signatures. And the next thing we want to discuss is intrusion prevention system, or we called it as IPS. So this is an active security system that detects and prevents malicious activities in real time. So it prevent before it happen, it prevent that. We called it as intrusion prevention system. So it takes real-time action to block attack, and it can drop malicious packets, reset connections, block IP addresses, and it act as a real-time security guard. So the interesting thing in here is it prevent before something happen, it prevent it. Prevent in the sense, fully we can control that thing. So we can control it up to not happening something. We called it as intrusion prevention system. Right. So let's go to the next thing, load balancer. Load is the heavy thing. Load is the package we are carrying. So here what we are going to do with this load balancer, we try to balance that thing. So first of all, you should understand what is load balancer. So it is a traffic distribution where distributes incoming network traffic across multiple servers. And we have something called overload prevention. It ensures no signal server becomes overwhelmed. And we have performance enhancement. It improves response time and facilitates seamless scalability. So it try to balance the heavy thing. It try to balance the heavy workload of the network or the internet. Right. And this is a small scenario where I want to take and give you the idea how this thing working. So this is a problem of building a small office network. Suppose you all are network related people and someone asks you to develop a small office network. So these are the step-by-step guides that you all can follow to develop something like this. So first of all, you have to focus the network requirements. So you have to understand the layers, requirements, and everything in order to develop this small office network. So let's design a network for a 20-person office with the following needs. First one, internet connection. That is where the modem to translate digital signals for ISP infrastructure. So you have to use a modem. So modem translates digital signals for ISP infrastructure. The network security. A firewall as the primary security gatekeeper. And then we have inter-network connectivity. We have something called wired connections, 24 port managed switch for desktop. And then we have wireless connectivity. Those are the devices you all have to understand. So in this picture, you can understand it very clearly. So these are the devices in your office premises. You have computers. So this represent that thing. So here we have the wireless access point. Through that wireless access point, you can get the internet. And then we have the router, firewall, modem internet. So here we have the large internet cloud from where we all take the internet. And then we use modems to convert that to feasible way. And through firewall, we protect that network. And through routers via these wireless access points, y'all can access the device. දැන් අපි මේ concept එක තේරුම් ගන්න ඕනේ. ඉන්ටර්නෙට් කියන්නේ concept එකක්. ඉන්ටර්නෙට් කියන එක අපිට ලැබෙන්න අපි request කරන්න ඕනේ. එතකොට ඒක modem එකකින් අපිට ඕනි form එකට convert වෙනවා, modulate වෙනවා. ඒක අපි ගාවට එනකොට අපි ෆයර්වෝල් එකකින් ඒක ප්‍රොටෙක්ට් කරනවා, ඒක ෆිල්ටර් කරනවා, මොනවා හරි issues problems තියනවාද කියලා බලනවා. ඊට පස්සේ ඒක through අපේ router එකට internet ඇවිල්ලා route එක through wireless access point එක හරහා තමයි ඔයාගේ laptop එකට internet එන්නේ. දැන් ඔයා මොකක් හරි network එකක් device කරනවා නම් මෙන්න මේ steps මෙන්න මේ phases තමයි follow කරන්න ඕනේ. Right. So this is a small real world network diagram. Usually when we do a network, when we do an internet related things, we draw diagrams, not only in network, in software development also we do this thing. Why we do this network and all? Because it makes things too easier to understand. You can always follow the diagram and accordingly you can work with that. So we have these switches, routers, firewall, modem, internet, wireless access point, user laptops, everything in this diagram. So you can place these things here and there, and later according to the purpose you can connect all these things together to show the pathway and all. So that is the end of today's lesson. We discuss about very important lesson. We deeply discuss about what are the uh, devices, concepts, what are the things we should focus when we do a network like this. So before I wind up the session, I would like to summarize what we have covered under lesson 4. In lesson 4, basically we discuss about the networking devices. So this we consider as the building blocks of modern network. And we discuss about the basic structure of network. Network is a collection of devices where we collected with the intention of sharing and communicating. In this network concept, we basically focus data, packets, and frames. When we do or when we develop this network, we basically follow two models. First one, OSI 7-layer model. Second one, TCP 4-layer model. And then we started with cables and connectors. Copper cable, we have two types, unshielded, shielded twisted pair cable, and then fiber optics, very popular these days. We can send very large data packets and data with that. And then we have NIC, the network interface card, where we connect the network internet cable to the computer. Then we discuss something about repeater. when we try to send or communicate for a long distance without breaking the signal, without reducing the quality of the signal, we can send it to the receiver with the help of repeater. It amplifies and regenerate your voice. Then we discuss about the hub where we want to connect multiple devices. Then we discuss about the intelligent hub. It can do something advanced than the usual hub. Then we discuss about the MAC address table where we record all MAC addresses whenever we need, we can access. Then we discuss about two types of switches, manage, unmanage. Manage switches are complicated, but it is very secure, very practical and good option. But when it comes to unmanaged, it is good for small scale home networks. It is very quick plug and play method and it's very cost effective. Then we discuss about routers. It is like a gateway. It will open the door for internet. We discuss about the routing table where we record all routing data. We did a small comparison between switch and router. We put switch under layer 2 and router under layer 3. We discuss the two different things with some practical examples. Then we discuss about a modem. It demodulate and modulate signals, convert analog to digital and digital to analog. Then we discussed about wireless router. Without wires, we can access the internet. With that, we discuss wireless access point, the firewall where protects our computer from outsiders. Then we discuss about intrusion detection system where we detect issues, where we detect threats. And intrusion prevention is the way we prevent those things. Then we discuss about the load balancer, how it balance everything. Then we discuss about a sample scenario with a practical network diagram. So those were the things I wanted to discuss today. So I hope you all get understanding about this lesson. Uh, we already started discussing the network devices last week and we are continuing with that. Please refer the recording, check the PowerPoint presentation and then come back to the next session. This is a full theory part, but if you need any clarification, if you need any help from me, please contact me. Definitely, I will help you to understand these things. So with this, I'm going to end the today's session. So this is the recording for 4th day of INT. So please refer all these things and get confidence about the topics, titles, and content. So thank you for listening and have a nice week for all of you. Goodbye.